Right? So sometimes graphical is really easy, like with a linear. Sometimes graphical can be really tricky with something that's polynomial. Now this one has even less points, but it has less curvy things. So maybe it won't be so bad. All right, so we only have 2 points. Right? So our function has the points 0, 2, and 1, negative 3. The inverse will have 2, 0, and negative 3, 1. So let's graph that. All right, so 2, 0, and negative 3, 1. There we go. All right, so those have to be on there. All right, so actually, this is a little bit easier to me because it's like 2 pieces that I need to reflect. What I also have to remember is this graph is not square. That's why my line y equals x does not go through the end. So I'm going to do that. So that might be a good strategy for you, making your graph square, because it does make it a little easier. All right, so now let's graph our function. And actually, maybe I should have these lines be something else besides the same color I'm graphing in. There we go. Okay. So now we want to reflect. All right. So over here I have this point. Right. So that point is going to have to correspond. So let's count 1, 2, 3, 1, 2, 3, 4, 5, 6, almost 6. So 6 horizontally is going to be 1, 2, 3, 4, 5, almost 6 vertically. Right? And this point here, right, because the function goes through that, is going to go through there. Right? And then we had the 0, 2. Right? And I don't know that we have anything else that's, why does one point seem 2 zeros in the wrong spot? Like something doesn't seem right. For some reason it doesn't stand out for me that where the origin is. That looks better. All right, so from here, see how well I can draw it. So I'll be forgiving if your drawing is teensy bit off. I don't know that I have the right curve in there. I'm losing the curve. So there's my origin. So all right, so it's kind of got like a curve to it. Let's see if I can use my line and let's make sure that's a slope of 1. Right. To help us out here. All right, so wherever I see a point on one side, I need to see a point over here on the other side of the line. Right, but that's too far. Ooh. All right, so see how I'm connecting corresponding points. All right, and then, because I just can't seem to get that little bit of a curve. All right, so now I'm a little farther away. Now I'm just a little bit here. So, and then I lost my other point. Where'd it go? All right, so our other point was over here, 1, 2, 3, 4, 5, 6, but not that far. All right, so if we just curve it a little bit more, finally. Whew, good enough. I say good enough. All right, we had one other point, right? And that was the negative 1, 3. And it's almost straight after that. All right, so we have to go through that point. And notice it comes almost straight down, right? It's just going to go a little bit this way. And so I'm going to tilt my head, and not bad. Sort of crooked, but not bad. I'll take that. So if you tilt your head, this one you can see the reflection better. I'd stink at making my curvies look right. Oh, that looks pretty good. I'll take that. All right, but you get the idea, right, how you can use your line of reflection. And the easier your function is, the easier this is. And then making sure your graph is square also helps out. Right? So if you've coordinate plane goes a little longer, kind of contain it in a square. All right? We're going to do, oh, that took a long time. This is our, I think it's our last one. Our last one. All right, we want to sketch the inverse of the function shown. All right, another curvy one. All right, and so this is going to be another parabola, but on its side. So we can kind of use that fact. We got to switch our points. All right, so there's our points. Right, so 0, -3. That's going to go to -3, 0. All right, so we'll graph that, and my -1, -0 is right smack in the middle on it. So -1, 0 is right here. All right, so 0, -3, where's 0? There it is. Oops, excuse me, -3, 0 to 3 right here. All right, so there's our point. I really shouldn't use red for the original function. We don't want to think that's our point. All right, so you can see how that's flipped, and actually this one I don't think will be as bad as the last two were, although the second one, the second graph we did after the linear, that was the toughest one. Then 1, 0, I'll write these separate. 1, 0 will go to 0, 1. All right, so that's going to be right here. Oh, this is already coming into play. And then -1, 0 will go to 0, -1. So that's going to be right here. Do you kind of see the shape it's going to be? All right, so now I just got to get the right width. So here it's a little bit more than 1, about 1.5, a little bit more than 1.5. So at the end here, remember this isn't square, so it's like a rectangle. It's longer, it's wider than it is long. So when you're trying to judge where points are supposed to go, switching x and y, it helps to have this be a square. That's why that line y equals x doesn't go to corner. By the way, I never did write that in. This is y equals x, our line of reflection. All right, so now this is going to be straight this way, and we have this. Now, before we go, look how easy that one was. Parabola is not too bad. Parabolas and lines, they're not too bad. Let's talk about whether these were functions or not. All right. First graph. Well, this one was a function, right? So here the inverse was a function. And we can tell because we could tell even before we graphed because the original function. So actually I'm going to write it with the notation. So f inverse was a function because f of x passed horizontal line test. It studied, did a really good job, did all its work, and passed the horizontal line test. If I draw a line, horizontal line, I'm only going to go through one and only one point on a line. How about this one? Let's use our line here. Oops. No, it took us so long. No, don't do that to me. Okay. It's not going to be y equals negative x anymore. Now it's going to be a horizontal line. All right, look at the purple graph. Are we passing the horizontal line test? Yes, 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 and look at here. 3 points. All right, 3 points, 3 points. I'm going through 3 points. Fail. It didn't study. It did lousy. It failed its horizontal line test. All right, so here, f inverse is not a function, and f of x fails the vertical line, the horizontal line test. Let's look over here. All right. Let's use my line again. Let's use y equals negative x again. Now it becomes a horizontal line. All right. Pass, 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 pass. It passes. Yay. So here, and actually if we turn this into a vertical line, I think the linear was easy to see, but let's turn this into a vertical line. Whoop. Let's see if our function passes the vertical line test. Yes, 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 or I should say our function. F inverse. Does F inverse pass the vertical line test? Yes, 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 yes. All the way through. I don't know what happened to my line there. All right, so here, F inverse is a function. F of x passes the horizontal line test. F inverse passed the vertical line test. We'll write that. And you should write this, by the way, on these graphs. So F inverse passes, F of x passes the horizontal line test. F inverse passes the vertical line test. Yay! They both studied. Just a little humor. Just a little math humor. All right, so our last one here. Did this one pass? Well, I hope you look at, we got given z. Does our function pass the horizontal line test? Right away, you can see negative 1, 0, and 1, 0. I've got two x's with the same y. It fails the horizontal line test. Here, I'll just use this line here. Look at how miserably F inverse fails the vertical line test. So here, F inverse is not a function, it's just a relation. It's a relation only. Because f of x failed the horizontal line test, and that means f inverse, oops, there we go. What happened to my 1? Good enough. Fails the vertical line test. Right? Because horizontal becomes vertical. All right, so to sketch the graph of the inverse of a function, reflect the graph of the function across the line y equals x. This will switch the inputs and the outputs, and that's how you graph. Some functions are easier to graph than others. All right? Parabolas, not too bad.